Hello, my dear aviation friendly friends, students appearing for pilot examinations, and others who are interested in aviation. Welcome back to Booty Aviation Training. And this is SK Booty here with the next lesson from navigation theory today. We will understand a little bit of theory. And after that, I will give you a few questions for your practice. Questions are useful for CPL, ATPL, airline exams. Well, as you know, these are the playlists already running on my Booty Aviation Training channel on YouTube. And keep watching, there'll be a lot more coming up by yours truly, SK Booty. Today's topic is theory questions from critical point, which is also known as equitime point or point of equitime, and a point called point of no return, which is now called point of safe return PSR, also sometimes known as ROA, radius of action. So let us first start with a little bit of theory. That is your critical point definition. Critical point, also called point of equitime or equitime point, it's a point on the track from where it takes equal time to either proceed to destination or return to your home base or any other suitable aerodrome. This is particularly important in those flights where no suitable midway diversions are available. Legs are long. Or in case of an emergency where time is critical, you must land at the earliest possible time. Then I would like to know, have I crossed the half time, point of equal time on my track? Emergency could be pressurization failure, engine failure, etc. So we calculate this point on the ground before departure. If the total distance departure to destination is d delta, ground speed on the outbound track is called O, and ground speed on the return track is known as H. Then distance of critical point, okay, amended to DISTANC, distance of critical point from the departure will be equal to D multiplied by H divided by O plus H. Critical point is also called equitime point, as I said. Now here you are. Let me carry out a small amendment while I'm at it. Now, under nil wind conditions, or when the wind direction is 90 degrees to the track, the critical point lies at midpoint. If there are winds, the critical point will get displaced from the midpoint upwind. That means from the direction from where the wind is coming. If it is coming from front, headwind, it will shift toward destination. If the winds are from your back, then it will shift to your back towards your departure point. By a distance equal to half the leg distance d by 2 into wind component by TAS. D is the total distance and wind component is the average of headwind component or tailwind component. Then second is the point of no return, known as now point of safe return or radius of action. It's the maximum distance outbound away from departure to which an aircraft can travel and return to the same base within safe endurance, which is also known as prudent limits of endurance. What is endurance? It's a maximum time an aircraft can remain in the air with a given fuel. And PSR endurance is the total fuel on board less the fuel which is reserve, which is for diversion, holding, etc., etc. Distance of point of no return is called capital R or DPNR. It is equal to endurance in hours. Fuel available divided by the fuel consumption. Take it in decimals of hours. Ground speed outbound multiplied by ground speed home divided by sum of O plus H, and time to the PNR will be this distance R divided by my ground speed outbound at which I must turn back, which is also equal to EH over O plus H. Maximum distance to PNR which you calculate will be under nil wind conditions, under headwind conditions, or tailwind conditions, or the crosswind conditions. The PNR distance will be lesser than what you calculate under nil wind. Whether there is a headwind or the tailwind on the outbound or inbound, as long as the amount of wind remains same, the distance to PNR will remain same, but the ETA will be affected. If there's a tailwind on the outbound, remember there'll be headwind on the inbound. So your ETA will be less. And if there's headwind on the outbound, your ETA will be after a longer time. It's primarily a fuel-based problem. Greater the fuel available for use, and greater will be your DPNR, and lesser the fuel consumption, greater will be your distance to PNR. A 10% increase in the fuel consumption will increase your PNR distance. Okay, not the PNR fuel, sorry, not the consumption, but a 10% increase in the PNR fuel available, your PNR distance will increase by 10%, and a 10% increase in consumption will result in 10% decrease of your PNR. This theory I covered it earlier also. Numericals have covered in the separate series. And let's go to the expected questions or most often asked questions from the topic critical point, PNR, PSR. Here are the 8 questions which I have given you. DCP is distance of critical point. TCP is time to critical point. And if you are on both engines and there's no emergency, then your CP and critical point will be coincident only if you are carrying only the flight fuel and nothing surplus. If you are carrying any surplus fuel, then the PNR will be after your critical point. Solve these 8 questions, apply all the knowledge you have, and only after that, don't be in a hurry, only after that, look at the answers. And here they are, questions 1, 2, 3, 4, 5, 6, 7, 8, and your answers. And before you switch off, if you have liked the lesson and benefited, do share it with your friends also. Share the channel with your friends. Don't forget to subscribe to my channel, like the video, and press the bell icon. I will also be looking forward to your valuable comments. Happy landings from SK Booty. And I will see you soon with the next video. Bye bye till then.